All right, so everybody should be looking at my naming the sides of a right triangle. And how do we name the sides of a right triangle? Well, look at the insert box. It says the Greek letter, and the Greek letter here, the symbol, is called theta. We use a lot of Greek letters in the sciences, and this particular one is very often used to designate angles. And of the different letters that are used to designate angles, we could use delta, we could use alpha, we could use beta, we could use any of a number, epsilon, but theta is the most popular for designating angles. That being said, it is to designate an angle of interest, because in this triangle, you only have 3 angles. One of them is the right angle, and then you have 2 remaining angles. And we want the angle here in this lower left-hand corner. Not interested in the one in the upper right-hand corner. I'm interested in the one in the lower left-hand corner. Why? Because that's where the symbol of theta is shown. It is called the angle of interest. Now, why are we interested and how do we name this? All right, so the second line says, with respect to to whichever angle is designated as theta, the sides are given very specific names, okay? One side, called the hypotenuse, will always be what? Opposite the right angle and will always be the longest side of a right triangle. That's the easiest one to identify. The 2 shorter legs of a right triangle have very specific names once I identify the angle of theta. One of them is called adjacent, and look at the definition very carefully. Which side is adjacent? It is the side that always meets the hypotenuse at the angle of theta. So here's the angle. In order to form the angle, you need 2 sides. One side is the hypotenuse. The other side that forms the angle of theta is called what, class? Adjacent. What's left over? What's left over is called opposite. And opposite is always on the other side, on the other side of the right triangle. In other words, it is opposite the angle of theta. So if this is theta, then this side, way over on the other side of the triangle, is opposite theta. This side is named opposite. Notice the 3-letter abbreviations that are given in this diagram. Hypotenuse is specified as HYP with a big capital H. Adjacent is abbreviated as ADJ with a big capital A. And opposite is abbreviated as OPP, because I don't want to write out the whole word. I'm just going to write down 3 letters, just like resistor color codes. We never wrote down BROWN. We just wrote down BRN for brown. So we're going to abbreviate these with 3 letters. It's very handy. Any questions about naming the different sides as long as you are given a theta? So let me give you something to think about. Suppose for a moment, let me stop the share on this guy and go back to my worksheet. If I go back to the worksheet, here I'm going to draw a triangle. I'm going to make this, and I'm going to call this WXY. And I'm going to put theta over here. So my sides will be there's an XY side, there's going to be a WY side, and there's going to be a WX side. Can you name each of these sides based on the right triangle, based on where I've designated theta? Can you name what this WX is going to be, what XY is going to be, what YW is going to be? So think about that for a moment, and I'm going to be calling your names. So question goes to, let's take a look here. Okay, Dana, I got a question for you. Can you name XY? XY is here to here. XY would be named what side of this right triangle? Dana, X to Y, this side right here, would have what name based on the convention that we specified earlier? I can't hear you, Dana. Maybe
Sorry, what was that? Could you repeat that?
Okay, yes. Given the illustration that I have, and from the information from the previous slide that I showed on PowerPoint, can you name XY, this side right here? Is this hypotenuse, adjacent, or opposite? What is the name that would go in here for X to Y?
Opposite.
Opposite. How many people vote for opposite? You click on the thumbs up icon. Cool. It is opposite. Good job. Okay. How about the WY? The WY goes to Andrew.
Hypotenuse.
How many people agree that WY is the hypotenuse? Give me a thumbs up. Just click your little thumbs up icon. It's on Canvas. It's on the bottom. There you go. Hypotenuse. And I'll abbreviate that. And then the remaining side, Tawan, WX.
Adjacent.
It would be called adjacent, and I'm going to abbreviate that ADJ. Okay, is everybody all right with how this is designated? I'm going to give you another one to think about. Let's do this one right here. Suppose I have this here, and I'll put this guy here. I'm going to call this W, X, and Y. Oops. X and Y. So W is some side, X is some side, Y is the name of some side. Question goes to, let's see, Kirsten, what is W?
Hypotenuse.
How many people agree hypotenuse? HYP. Good job. X. Question goes to Ryan. Ryan. X is called what side?
Opposite.
How many people agree with opposite? OPP. And Y would be adjacent. Why would Y, why would the side of Y be adjacent? What's my definition for the adjacent side? Ephraim. Just because it's left over? No, what is the definition for adjacent? Your microphone is not very clear. Okay, we can't hear you. Yeah, we still can't hear you very clearly. So here, let's move on. So the reason why this is called adjacent, if you look at the definition on this slide, adjacent always meets the hypotenuse at the angle of theta. Adjacent is one of the sides that forms the angle of theta. And so the long side is hypotenuse. The other side that forms the angle of theta must be adjacent. That will be adjacent, that will be hypotenuse, and this on the other side is going to be opposite. So is the naming of the sides pretty straightforward as long as you're clear on the definition of hypotenuse, adjacent, and opposite, as long as we designate where angle theta is, all right? Now suppose for a moment I do something else here. Suppose for a moment I make this guy, suppose for a moment I make this guy angle alpha. This is a symbol for alpha. So with respect to alpha, alpha,
the naming.
So here, yeah, let me go ahead and change this. Stop the share and go back to my camera. All right, so if I name this other angle here alpha, then does the name of these sides change? W now becomes what? Question goes to Luis. If I'm interested in this angle called, if this becomes the angle of interest called alpha, what is the side of W now?
It was the hypotenuse.
It still is the hypotenuse, right? That doesn't change. It's still the longest side. All right, good. How about the side of X? Question goes to, let's take a look here. Question goes to Carlos Navarro.
It would change places with Y, right? So it'd be adjacent.
So this would be adjacent. How many people agree that this would be adjacent? Because again, the hypotenuse and this side form the angle of theta. So that means in this particular case, this would be the adjacent side with respect to alpha. Okay, and then the remaining side is going to be opposite. Okay, everybody all right with the naming conventions? Pretty straightforward so far. All right, now we jump into the meat and potatoes of this evening, and that is this, Sohcahtoa. And Sohcahtoa is right here. It's a memory tool. And look very carefully how Sohcahtoa is spelled. This goes right into your journals. So is spelled with a capital S-O-H. Ka. As you go to speak the word ka, everybody say ka. And as you say ka, the very hard C is the leading letter, A-H. The sound of your pronunciation helps you with the letters. So ka is C-A-H. And the last one is pronounced toa. So toa, 2 syllables. To with a hard T, starts with a T for toa, O and A. Now what do these groupings of 3 letters do? It is a memory tool that cites the relationship between the trigonometry functions and the sides of a right triangle. Very simply, if you look at this illustration here, sine, cosine, and tangent are basic trigonometry functions. And the sine of an angle is equal to a ratio. Right here's the ratio. The ratio is going to be opposite over hypotenuse. So as you look at this very carefully, look at what I've written on the right-hand side. SOH, the sine, and I capitalize this S for sine, of an angle is the ratio of opposite over hypotenuse. Can you see the S, the O, and the H as part of an equation? Okay. Ka, cosine, designates a ratio of adjacent over the hypotenuse. And take a look on the right-hand side. Ka is the cosine of an angle, is the ratio of adjacent over hypotenuse. Can you see the C, the A, and the H forming the word ka? And lastly, we have toa, T-O-A. The T stands for tangent. So the tangent of an angle is the ratio, oops, not ration, sorry. Back up. Oops. Ratio. The ratio of opposite over adjacent. Can you see the T, the O, and the A? All right. Now, underneath each of these relationships is ultimately the formula that we want. The formula we want is not so much the sine of an angle, we want the angle. So look at the very first one on top. So is the sine of an angle equal the ratio of opposite over hypotenuse. Thus, the angle of theta, this is how we mathematically calculate the angle. The angle of theta is the inverse tangent, open parentheses, opposite over hypotenuse. Inverse tangent of opposite over hypotenuse. So, nope, sorry. Did I do inverse tangent on everything? I think I did. So this is inverse sine. Nope. And this one will be inverse cosine. Too much cutting and pasting. All right. So here we have an S. I'll do that in red. We have an O. Do that in red. And we have an H. I'll do that here. Okay. So let's go ahead and try to see if we can apply this to this particular example here. Given this particular triangle, take a moment and copy it down. Theta, 618 and 267 x. Okay. So let's go ahead and identify what x, y, and z are first. We have to identify x, identify the side of y, identify the side of z with names, which is opposite, which is hypotenuse, which is adjacent. So the questions will go out to Abbas. Which is the side of, what is the side of x?
The side of x is adjacent.
How many people give a thumbs up for adjacent for the side of x? 2 people, 3 people, 4. Okay, it is correct. ADJ is adjacent. And then the side of y, the question for side of y, Javier, how do you
Opposite.
name, how many people agree that the side of y over here is opposite the angle of theta? OPP, thumbs up. And the side of z, pretty straightforward. It's the longest side. That will always be the hypotenuse, yes? Cool. Now, what sides are we given? Okay, don't calculate the remaining side yet, but what sides are we given? Well, you're given adjacent, and you're also given opposite, yes? You're given the adjacent, and you're given opposite. Very interesting. So between the trig functions that I introduced you to, you had a SO, you had a CAH, and you had a TOA. Those are the 3 memory tools that we'll use. Let's go ahead and go to stop this share. And this is what we have. Yes, you have your triangle that you copied. X is 618, Y is 267. We called out X as being adjacent because it helps to form one of the sides for the angle. The other side will be the hypotenuse. So this is clearly adjacent. So that's good. We confirm that. Opposite is on the other side of the triangle from angle theta. So yes, we're happy with that. And then the longest side is the hypotenuse. We're happy with naming that. Now you're given 3 memory tools. You're given a SO, a CAH, and a TOA. And depending upon what you're given will determine which one of these 3 names you're going to use. How do you know which one we're going to use? Check this out. Adjacent starts with what letter, my friends?
A.
I have an A. Opposite, the side is given as 267. You called it out as opposite. This starts with what letter?
O.
You have an A and an O. Does SO have an A and an O? Nope. Does CAH have an A and an O? Nope. Does TOA have an A and an O? Yes. Use TOA. Use TOA because there is an A and an O that is given. So when we use TOA, we said that the tangent of an angle of theta is equal to a ratio O over A. What is O? Opposite. A is adjacent. So what I'm writing down is the general formula. What we're interested in is not so much the tangent of an angle, we're interested in the angle. So how do I move tangent from one side to the other side? On the other side, it becomes inverse tangent. And then I'm going to put in parentheses this ratio. Do I have a value for the opposite side? The value for the opposite side is given as 618. Do I have, oh no, sorry, messed up. Okay, the opposite side is given as 267. And what is the adjacent side? The adjacent side is given as 618. Then close parentheses. So how do I key this into the calculator? It's blazingly simple. On your calculator, your tangent function is shown as a yellow function, tangent -1. So you have to hit the shift key. So on your calculator, you will do shift tan. Now let's see what happens when we do that. Shift tan does not open a parentheses for us. We need to open parentheses. On some calculators, it automatically opens up parentheses. This one does not. Then let's key in 267, and it will be divided by 618. And then you have to remember to close parentheses. Then you hit equals. So shift tan, open parentheses, 267, divide by 618, close parentheses, and then hit equals. And then hit engineering. And I am looking for a degree for this particular angle. Question goes to Chisomaga, my friend. What do you calculate?
I'm at 23.37 degrees.
Speak a little more steadily into your microphone.
23.37 degrees.
23.37 degrees. How many people concur? Give me a thumbs up. How many people are having a challenge with this calculation function on their calculator? You do shift, tan, open parentheses, 267, divide by 617, close parentheses, equals 23.37 degrees. 23.37 degrees, yes.
Could you look at my calculator and tell me what I'm not doing correct?
Let's see, you're using...
The TI 80
TI.
plus.
Sure, okay, so on the TI, turn on the thing, clear, clear, clear. And on this one, inverse tangent, in this calculator, it automatically does generate the open parentheses, and I will key in, oh, I know what you're not doing. I know exactly what you're not doing. It's okay. This is a fast fix. Divide by 618, close parentheses, and you don't get the 23.3666. You don't get this, right?
Yeah, I think I just didn't realize it was the tan inverse, because whenever the keying was listed out, it just said tan, so I didn't do it.
Well, here, let me caution you one more thing. On these calculators, you have to hit the mode, and you have to make sure that we are not in radians. We have to be in degrees. Okay, make sure you are not in radians. You want to make sure you're in degrees. So you bounce down, hit make sure degree, and hit enter. Otherwise, it'll give you a calculation in radians. Okay. So
thank you.
You're welcome. All right. Anybody else have any calculator questions that I can help you with in order for you to get this number? So we believe that this one will be 23.37 degrees. All right. Now we're going to double check that. How are we going to double check that? There's a couple ways we can double check. Who's got a suggestion how we can double check this number? There's a number of different ways we can double check.
180 minus 90 and minus
180 minus 90, and then what?
minus 23.36.
23.366666, yes. And then what does that give you? What would be the result?
Give us another angle.
Mm-hmm. It would give you this angle over here. And this one we will call alpha. Okay, so let's call this particular side, use a different color here. Let's call this side alpha. Okay. We're going to calculate the side of alpha to double check theta. So I'm going to make this guy the angle of interest now. This is alpha. So alpha, the Greek letter alpha looks like this. It's kind of a loopy thing, like so, and it's called alpha, right? So this becomes our angle of interest. So if this is our angle of interest, how do we rename these sides relative to alpha? Because here's the sides that form the angle of alpha. So hypotenuse doesn't change. Hypotenuse is still right here. It's still always going to be the longest side. But what is the other side here that makes up alpha? Is it going to be x or y?
X.
Why?
Y is going to be now the adjacent side. Does anybody have any issue with that conceptually? If this is the angle of interest, angle is always made up of two sides right here. One of them is the long side, which is the hypotenuse. This side here that makes up the angle of interest, in this case alpha, is got to have a name. This will be the adjacent. This was opposite for theta, but this is adjacent for alpha. Are we okay with that? And then, which means the remaining side way over here, x becomes what, my friends? Opposite. So now, how do we calculate the angle of alpha? The angle of alpha would be could be calculated this way. Let's go ahead and fold this guy up. And very quickly do this. So we have alpha in this corner. We have 618 over here. We have 267 over here. And we are given this is now the adjacent side. And this is now the opposite side. And we are looking for first letters. What is the first letter of the word adjacent? An A. What is the first letter of the word opposite? An O. So from Sohcahtoa, which of these three names has an O and an A? Again, it has Toa. So we will use Toa. So T-O-A, because I have an O and an A. What does that tell us? It tells us that the tangent of angle alpha is equal to a ratio. What's my middle letter? O. Second letter is an A. So what's my ratio? What over what?
618 over 260.
I'm going to write out the names first.
Oh.
Opposite over adjacent, okay? So we'll always write out our formula first. That gives us a roadmap. So now what I'm going to do is fill in the roadmap. I don't care about the angle of alpha. I don't want the tangent of the angle of alpha. I want just the angle of alpha. So that means tangent is going to go to the other side. And in parentheses, what's my opposite value? (618) over 267. Is that right? Okay, Francisco, call out the keystroke sequence for me on our calculators.
Shift,
tan.
tan,
Okay, and then tan.
open parentheses, 618
Open parentheses, 618
over 267,
267.
close parentheses.
Close parentheses equals.
Mhm.
And the question of the value will go to Erica. Erica, do you have the value of this calculation? What this calculates to be?
Yeah, I got 66.63 degrees.
66.63 degrees. How many people agree with 66.63 degrees? Give me a thumbs up. Nobody gave us a thumbs up.
Thumbs up.
Okay, yay, one thumbs up. Any other thumbs up?
Another up right here.
Okay, yay, all right, so 66.63 degrees. I'll write that so it's a little more contrasty. Wow, so we calculate this angle as 66.63 degrees. Earlier, we calculated this one as 23.37 degrees. Did we just verify, did we verify our first angle by calculating the second angle using Sohcahtoa? Because if these two angles add up to 90, and we have 90 in this corner, then all three internal angles of a right triangle add up to 180. We're happy campers, aren't we? So I don't recommend using the subtraction method. I don't recommend 180 minus 90 minus 23, and whatever's left over must be the leftover angle. Don't recommend that. Why don't I recommend that? Because if this is miscalculated, if this is an error, this will be an error also. We don't want that. We want to calculate this one separately, okay? All right, let's try another triangle. Let's see, another triangle. I have a bunch of them. Let's go ahead and do this. I'm going to give you here. And this will be 745. And stop. And this will be 327. And I'm going to give you an angle of interest. The angle of interest here will be this guy right here. Here will be my theta. And this will be, let's call this particular one E. Let's call this F, and let's call this G. So we have a side E, F, and G, and there's the angle of theta. I am looking for the name of this side. I am looking for the name of this side. I am looking for the name of this side for this particular triangle. So copy it down. This side is G. This side is F. This side is E. We can calculate the length of this easy. That's not an issue. We want to practice our sine, cosines, and tangents. So that means we have to name these sides. So as we're looking at this, question goes to Luis. Luis, help me out. What is side E called?
Side E is the hypotenuse.
Side E is hypotenuse. I'll abbreviate that HYP. That's kind of hard to read. Let me use the darker color. HYP. All right. And the next one is the side of F. Kirsten, what is the side of F? Kirsten, the side of F. Not there, it's okay. Andrew, what is the side of F?
F is opposite.
Okay, F is opposite, you are correct. And the side of G, which helps to form the angle right there, must be, because one side's hypotenuse, the other side must be adjacent, yes? All right. So that being said, let's go ahead and write these names. We have an HYP over here, we have an ADJ over here, and we have an OPP over here. Cool. Now, what are our givens? We're given the hypotenuse and we're given the opposite. The hypotenuse has a value. The opposite has a value. What's the very first letter in the word hypotenuse? Is an H, yes? What is the very first letter in the word opposite? O. You have an O and an H. And here are your three options. Sohcahtoa. O and an H. Does Toa have an O and an H? It has an O, but no H. Does Ka have an O and an H? It has an H, but no O. Does So have an O and an H? It does. So cool. That's how you determine which trig function to use, by your givens and by your assignment of the names of the sides. You assigned hypotenuse, you assigned opposite, you look at the first letters, you're going to be using so. What does that tell us? The sine of angle, SIN, I'm going to abbreviate, sine of angle theta is equal to a ratio. So the first letter is S for sine, second letter is O, which is my numerator. O stands for opposite. And H is my last letter. It stands for hypotenuse. It goes into the denominator. This is the formula of what we're going to use. The sine of an angle theta is equal to opposite over hypotenuse. Now, again, we're not interested in the sine of an angle. We want simply the angle. Therefore, when we move sine from one side to the other side, it is going to be inverse sine. And in parentheses will be the opposite of 327 over the hypotenuse of 745. And when you go to do this, can you call out the keystroke sequence for us, please? Question goes to Benjamin. Ben, are you there? Gregory, could you give that to us, please? Keystroke sequence.
Is it parentheses 327 divided by 745?
Well, I wrote out the angle of theta is equal to inverse sine, open parentheses, of this ratio. So based on what we did previously, is we have to key in an inverse sine function. How do we do that on our calculator?
Shift.
That's right. You start off with shift.
Then sine.
And then sine, which is identified by three letters.
Yep. Then open parentheses.
Then open parentheses, correct.
327.
327 divided by 745.
Close parentheses.
Close parentheses.
Enter. And then
Enter.
engineering.
And then engineering, yes. And when you go to do so, what is it that you are able to calculate there? Question goes to Harpreet.
26.04 degrees.
And 327 divided by 745, close, and engineering. So you have 26 point what?
04 degree.
04. And we use a little tiny circle here to indicate degrees. How many of you agree with 26.04 degrees? So far, so good? Cool. Now, we're going to verify this. We're going to verify this by doing something a little different than what we did a moment ago. We're going to verify by looking for angle of alpha. And actually, maybe even not. But let's see what happens. Could we calculate for G? Can we calculate for the unknown value of G? How do I find the value of G? Using Pythagorean theorem. Remember, in Pythagorean theorem, a squared plus b squared equals c squared. Is this the hypotenuse or one of the shorter sides?
Shorter sides.
One of the shorter sides. So this would be a squared is equal to c squared minus b squared. That's one of the shorter sides. It's always going to be the longest side, and we're not going to add here, we're going to subtract. Now I only want a, I don't want a squared, so what do? A is equal to the square root of c squared minus b squared. That being said, this is equal to the square root of 745 minus 327, and each of these are going to be squared. So how do I key in the keystroke sequence for this particular guy? Question goes to Tony. Can you call out the keystroke sequence for this?
Hit the square root,
Hit the square root key. There I am.
open parentheses,
Open parentheses key. Okay, there I am.
745,
745.
square root,
Square root?
2,
Did you say square root?
2. Yeah.
Did you say square root?
No, the x square.
Okay, so simply square. That's all you have to say. Yes, square, the square key.
Minus.
So we have a minus. We don't have a plus here. This is a minus. Good to remember. 327
Square.
Squared.
Close parenthesis.
Close. Yes, we got to remember to close.
Equal.
Equals. And then hit engineering.
Engineering.
What do you get?
669.40.
669.40. How many people give us a thumbs up? Uh-oh.
No.
I have 1 thumbs up, 2 thumbs up. That's pretty good. It's always, 3 thumbs up, 4. All right. Doesn't it make you feel good? Yes, there's a few people backing you up. All right. So this is equal to the unknown side. So watch how we're going to double check our angle by using a totally different math function here. And we're going to double check this very, very quickly. If I can find one more. I know I have more. One more. All right. So very quickly, we have from our original triangle here, here, and here. We have a 745. We have now a 669.40, and we have a 327, and our angle of theta is still here. Let's double check this, my friends, by using these 2 sides here. Let's double check the angle of theta by using our newly found side of 669.40. So as you look at this, the angle of theta is formed by 2 sides. One is the hypotenuse. The other one will be the adjacent, yes? That's the adjacent, that's the hypotenuse. We didn't have the value of the adjacent side until now. So as you look at this very carefully, hypotenuse starts with what letter? H. Adjacent starts with what letter? A. Wow. So you have a so, you have a ka, and you have a toa. Which of these are we going to use? Are we going to use so, ka, or toa? You have an A and an H. Yes. Everybody okay? We're gonna use ka in this particular case, yes? Because you have an H and you have an A. So what determines which one of these you use will be whichever sides that you're going to use to calculate that angle. So what does this do for us? It says that the cosine of the angle of theta, that's how we speak this, is equal to some ratio. The C is the cosine, the A is my numerator, the H is my hypotenuse. The numerator A stands for adjacent. H is my denominator, stands for hypotenuse. Do I have an equation for the cosine of an angle? Yeah. Do we want the cosine of an angle? Nope. We want the angle. How do I move cosine from the left side of this equation to the right side of the equation? I change it to inverse cosine, like that. And in parentheses, I will have adjacent of 669.40 over 745. So the keystroke sequence, I'm going to ask Ryan, please call out the keystroke sequence for me, please.
So you hit the shift button
So I'm going to hit shift,
and then cosine,
then cosine, COS, then
and the left open parentheses,
the left or open parentheses, simply.
and then you put 669.4 divided by 745.
Got that.
You close it with the parentheses.
And close with parentheses.
And then hit the equals.
Then hit equals.
Engineering.
And probably engineering also. And the calculated value works out to be what value here? Erica?
I got 26.04 degrees.
26.04 degrees. Was that really close to the angle we had calculated a number of pages ago? No, we calculated 20, oops, not that page, I'm sorry. Where did I move it to? One of these, yeah. Nope, too many pages here. Where did I put it? Not that one. Not that. Did I lose a page? I'm so sorry. Where did that page go? No, not here. Not this one, clearly.
Did you fold it?
Did I fold it? No, this one's blank, but I probably folded it in here somewhere. No, that one's blank. All right, so I'm looking for my original picture. It wasn't this one, and it wasn't here, and here. Oh, yes. I didn't write it up here, but we calculated earlier, 26.04. Wow. We verified that angle by using a different trig function. This first angle of theta was calculated using the sine function. This time, because we calculated the missing side, we now use a different trig function, CAH, and we end up with the same angle. Isn't that marvelous? We have the same angle verified using two different trig functions simply by calculating the remaining angle. Okay, this concludes what I want to get across to us today because we're going to be needing this math in the next 2 weeks with capacitors and with inductors. It's not hard math, and for some of you, you may not have ever seen Sohcahtoa before. How many of you have actually seen Sohcahtoa before? Give me a voice shout out.
Yeah.
Yep.
Yeah.
Okay, some of you have? Okay, that's good. And if you have,
Yes.
then it's a refresher for you. How many of you have not seen Sohcahtoa before?
I have not.
Okay, and there's going to be, 2, 3, Harpreet hasn't either. So there's going to be some people who haven't seen Sohcahtoa before. But this is the extent of trigonometry that we're going to do. It's this simple. This is the only trig that we're going to ever be involved with is with Sohcahtoa. We don't do any more triangle math than this. There's no law of sines. There's no law of cosines. This is not a pure geometry class. I've taught that for 3 years, and it's fun doing proofs and stuff. We don't do any of that. This is as far into trig as we ever get. And I'd like to say that it is something that most people will develop a pretty high level of comfort with when they practice this a little bit. Okay? Okay. Any questions on Sohcahtoa? Because I will develop probably one more exercise for you that I'll add to the sheet. Okay.